How do you make a peanut butter and jelly sandwich? Well, first you get out a knife and the ingredients. 2 slices of bread, peanut butter and jelly. Then you use the knife to spread jelly on one slice of bread and peanut butter on the other slice of bread. Finally, you put the slices of bread together. We just created an algorithm for making a sandwich. Welcome to Grokking Algorithms in Motion. I'm Bo Carnes, and I will be teaching this course based on the original book by Adit Bhargava. This course is aimed at anyone who knows the basics of coding and wants to understand algorithms. You may want to find an algorithmic solution to a problem you already have, or maybe you want to understand what algorithms are used for. This course is designed for beginners, but is also great for computer science grads looking for a refresher. You'll need to know basic algebra, and you should be at least a little familiar with one programming language. You should be able to understand the math in this course if you can solve this problem. Given the function f of x equals x times 2, what is f of 5? Yep, you're right. The answer is 10. As for the programming language, all the examples in this course are in Python. I only use the basic features, so as long as you are familiar with at least one language, you shouldn't have too much trouble following along, even if you have not used Python before. The first 3 units of this course lay the foundations. I start right away with a practical algorithm. In Unit 1, which is this unit, you will learn about binary search, and then you will learn to analyze the speed of an algorithm using Big O notation. Big O notation will be used throughout the course, so it will be good to learn about it at the beginning. In the second unit, you'll learn about arrays and linked lists. These are fundamental data structures and are both very basic ways to store many types of data. They are used to make more advanced data structures like hash tables, which you will learn about later in this course. Then, in Unit 3, you'll learn about recursion. This is a technique used by many algorithms, such as quicksort, to make them more efficient. Big O notation and recursion are often challenging topics, so I'll spend extra time on those concepts. After Unit 3, you will learn about algorithms with broad applications. You'll learn about the divide and conquer problem-solving technique in Unit 4. Hash tables are covered in Unit 5. A hash table is a data structure that contains sets of key and value pairs, like a person's name and their email address, or a username and the associated password. They are extremely useful in many situations. There are many software problems that can be solved with either a hash table or a graph. So Units 6 and 7 are all about graph algorithms. Graphs are a way to model a network, such as a social network, a network of roads, or any other set of connections. Specifically, Unit 6 is about breadth-first search, and Unit 7 is about Dijkstra's algorithm. These are ways to find the shortest distance between 2 points in a network. You can use this approach to calculate the degrees of separation between 2 people, or the shortest route to a destination. In Unit 8, you will learn about a problem-solving technique called dynamic programming. Sometimes there is no efficient solution for a software problem. In that case, you can get an approximate answer using a greedy algorithm. Learn about that in Unit 9. In Unit 10, we will learn about a simple machine learning algorithm called k-nearest neighbors, or KNN. You can use k-nearest neighbors to build a recommendation system, an OCR engine, a system to predict stock values, really anything that involves predicting a value or classifying an object. Finally, Unit 11 introduces 10 other algorithms that you may be interested in learning more about. I won't go into much detail on these, but I'll point you to other resources so you can get more information on those that are most relevant to your work. It's best to go through this course in order, as each unit builds on the previous ones. However, if you are really interested in a topic, feel free to go directly to it. I'm going to show you a lot of code during this course, and it's best to execute the code yourself. This will help you to retain the information better. There are also exercises and projects that I recommend you do. They will help you check your thinking, so you'll know when you're off track before you've gone too far. Now you have an overview of the course, but let's get a little more basic. What exactly is an algorithm anyway? Well, an algorithm is really just a set of instructions for accomplishing a task, like the algorithm to make a peanut butter and jelly sandwich. Every piece of code could actually be called an algorithm, but the algorithms for this course were chosen for inclusion because they're fast, or they solve interesting problems, or both. Here are some highlights of what we'll be learning about in this course. Algorithms can really speed up your code. In one example from this unit, using binary search, the number of steps needed goes from 4 billion down to only 32. A GPS device uses graph algorithms to calculate the shortest route to your destination. And you can use dynamic programming to write an AI algorithm that plays checkers. In each case, I'll describe the algorithm and give you an example. Then I'll talk about the running time of the algorithm in Big O notation. Finally, I'll explore what other types of problems could be solved by the same algorithm. Every algorithm in this course probably already has an implementation available in whatever programming language you want to use, so you won't actually have to write the algorithm yourself. Still, we'll go over some implementations in this course to help you better understand the algorithms. Each algorithm implementation has trade-offs that are important to understand. So in this course, you will learn to compare trade-offs between different algorithms. Should you use merge sort or quick sort? Should you use an array or a list? Just using a different data structure can make a big difference. Also in this course, you will learn techniques for solving problems that might have been out of your grasp until now. Also, you'll know some of the most widely used algorithms. You can then use your new knowledge to learn more about specific algorithms for AI, databases, and so on. So let's get started.